In this video, we're going to start to learn about pointers. So pointers are a little subtle, but it's really important that you understand them. So to start off, let's look at a file that I've got here. And so let's just see how to even declare a pointer. So our pointers are always going to point to a certain type. So for example, let's say I declare an int, just like we know how, we've done a million times. And if I want to declare an integer pointer, so in general, the syntax will just be the type that I'd like to point to, and then I can use the star, and then my variable name. So if I want to call my variable p, then my pointer, p, then I use the star, and now I've declared this as an integer pointer. At this point, one thing to note is that pointers take up 8 bytes. So if I wanted to look at the size of both my int, let's see, size of int, and this is going to be, I think it's a long integer for some reason, but I can always look at my size of, and I can pass in a type here, and let's see what the size of my pointer is. So all pointers are going to be 8 bytes, whether it's, I think I can look at a specific variable. So let's do size of my variable n, which I know is, what does it say? Implicit declaration. Oh, I'm not saying printf. Oopsies. Okay. So I'm going to print the size of my variable n, which is int, and the size of my pointer p, pointer to an integer. So let's compile here. And, oh, I guess it's not a long, it's just a long. So I would get rid of these, and now I don't get any warnings. Okay, so the size of an int for my compiler is 4, and the size of the pointer is 8. Now, we've seen how to declare our integer pointer, but let's actually, I don't even have a comment for this, set values for, yeah, we'll set for n and p. Oops, for n and p. So let's just say I choose some value for n, that's going to be 151, and p, I want to point to n. And so what I say is, I say p is equal to is assigned to be the address of n. And so you might remember that the ampersand is the address of operator. So like I said, we've used this in scanf. This is how we pass by reference. So when I pass in the address of something, I can pass it by reference, but we'll go over this in another video. Here I'm setting p, which is an integer pointer, to point to n by setting p's value to be the address of n. So let's just take a look at what these are. So I want to print value of n is, and that's just a integer placeholder, and address of n is, actually I kind of like these, I think with some tabs. Let's try that. And address of n is, and I think this, oh, yeah. So addresses are 8 bytes, so I can print them using long. or I could print them as pointers. So maybe let's see what happens when I print it as a pointer. So %p is the placeholder for a pointer, but how do I get the address of? It's just the address of operator. Now, and what doesn't it like? Oh, I keep saying print. Wow, I'm just not in the C programming mood here, I guess. No printfs. Okay, so let's take a look at what this prints. So we're going to need to recompile, and so here we can see that our value of n is 151, just like we thought. And here we're printing the address of n, and you might notice here that I'm getting this value that has letters and numbers in it, and that's confusing. And it also starts with this 0x. So what this is this is just a more compact way of printing a long number. This is the address, the memory location, and so if we want to see this, this is being printed as a hex number. So in addition to using digits 0 through 9, it's also using some letters so that it can be base 16. So our regular decimal numbers are base 10, so we just use 0 through 9 as the digits. So they need 6 more to do hex, but I like to print these out. If I really want to be diving deep and understanding, I like to be as comfortable as I can be, and so I like to actually just print these as integers. So I'm printing a pointer type, but if I just put the long integer placeholder here, I can actually look at this as an int. And so let's do this. So it's the compiler is going to give me a warning that I'm printing a pointer with long unsigned int here. But I'm just going to ignore that so that I can look at this as an int. So now let's run it. And so now I have a super long number that's giving me the actual address of n. And if we run this more than one time, we can see we're going to get a different address, right? This memory address can be whatever it decides to be. But if I printed it again, I would get the same thing again. Okay, so now I want to print the value and the address of my pointer. So my pointer is p. So the value of p, if I just print it, so now if I left this, the compiler is going to want me to put this as a type p, type pointer, but I'm again going to print it as a long unsigned int. And then address of p, again, I'm going to print as a long unsigned int. And that would be address of p. All right. Now, again, I'm going to get my warnings, but that's okay. And now we can see, so this starts helping us understand what actually is this pointer business. So the address of n is this super long thing. I'm just going to represent it with the last 3 numbers. So the address of n is, or maybe the last 4, 1628, because everything before that's exactly the same. The value of p is also 1628. And so what is p storing? P is just storing the address of n. Where do we find n? And then if we want to also understand what is the address of p, well, it's just 1616. So I think it can be useful to actually draw this out for ourselves. So I've got a little cast from my iPad here. So at memory address 1628, we have our memory cell here, and it has our int n, which has value 151. So that was our int. We could have declared that like int n equals 151. And then we also declared an integer pointer, like so, and we said that this integer pointer should point to the address of, oh no, okay, whew, drawing an ampersand is hard, the address of n. So now, add another memory address, which was 1616. I have another memory cell, and so that's for P. And what is P storing? It's storing 1628. All right, let's come back here. Okay, so if I want to get to the value that a pointer is actually pointing to, I use what's called the indirection operator, or indirect reference. And so let's see, I'll just copy one of these. So I want to say value that P is pointing to, and I'm just going to guess that I don't need one of those tabs. And so we know that P is supposed to be pointing to an integer, right? So I'm just going to go ahead and put my integer placeholder. And then this indirection operator, again, is the star. So this is one thing that I think you will be justifiably confused by, but when we declare pointers, we put the star in front of the name. When we want to access the thing that they are referencing, we also put the star in front of the variable, and we call that indirection or indirect reference, or the indirection operator. So let's see what we get. Okay, value, oh, in fact, I didn't even need any two tabs. Let's try that. I just want my nice formatting here. Aha! So, value that P is pointing to. So, when I do something like what is star P? It's 151. Because what do I mean when I say star P? Star P says go to P and then follow whatever this memory location tells me to go to. Well, 1628 tells me to go here, and that's holding 151. And so that is what a pointer is. Let's look back. If we had anything else that we wanted to do in this file. So we can do things like what if we just wonder, what is P plus 1? Let's just print it out. So I'm just going to make a guess that it's going to be another memory address. So I'll use my long unsigned int thing here. And if I then ask, what is that pointing to? Value that P plus 1 is pointing. And this, I think, is an integer. I actually don't even know. Let's see. So we have P plus 1. So I'm just going to put some parentheses in here. And then how do we get to the value that p plus 1 is pointing to? We use the indirection operator. And let's take a look at this. I think this is again just telling me, yeah, same warning. This p plus 1 is a pointer, but I'm using the long unsigned int so that I can have it as an int instead of a hex number. So maybe if we go back over here, so now when I did p plus 1 is at memory address, again, I'll just use the last four numbers, 8752. Oh, these are new memory addresses. But we'll still say 8752, and it's pointing to some value. So this is something that we haven't initialized. So we don't know what this is. This is just what's there at this memory address. Okay, so let's see. We'll just do one more thing here with our pointers. There's a lot of examples in, I'm going to copy from public examples chapter 6, and let's take a look at pointer2.c and copy it right here. So let me look at it, pointer2.c. So let's try to understand what this code is doing. So first we declare and initialize two integers, and here we declare two integer pointers, and now we say integer pointer MP, or pointer to M, has value address of M. So we might say MP is pointing to M, and integer pointer NP has value address of N. So now we can use the indirection operator to access the memory location of M and N. So if we said star MP, so here we're setting whatever MP points to, so that's M, and we're setting it to whatever MP points to, that's M, plus whatever NP points to, and that's N. And this line here is similar, and so I guess let's try to make a prediction about what should happen. So after this, okay, we start with M was 10, so new M is 10 plus afterwards M is 10 plus 5 is 15, and then let's see here, so N was 5, M was 15. So after we do this, so whatever NP points to is N is getting set to whatever M points to, that's M is 15, minus whatever NP points to, which is 5, so afterwards N gets set to 10. Wait, oh wait, no. Yeah, if 15 minus 5 is 10, perfect. Okay, so now what should these print? So this first line, we print M, which is 15, and then we print whatever MP points to. Well, MP just points to M, right? So it's going to print 15 again. And then it looks like we're going to have a new line, so I guess I'll make a new line here. And then we're going to print n. We said n was 10. And then we're going to print a space, and then we're going to print whatever np points to. And that's going to be 10 again because np points to n, and n is 10. Now let's look at this next line. This is going to print whatever MP is. So MP is what's held in MP is just the memory location of M. So, and then the second thing, argument right here, that's explicitly saying address of M, right? So that's also a memory location of M. And then we could use the same logic on the next one. This is the memory location of N and the memory location of N. And I guess I got some typos in here, probably some other ones around, but okay. So now we've understood this. We expect to see 15, 15, 10, 10, and then some memory locations that are the same on two different lines. So let's compile it to pointer 2, and we're not going to get any warnings because we're not using the long ints or anything, the long unsigned ints. But so we got what we expected. And down here at the bottom, so these are the memory locations in hex instead of in decimal. So that is our intro to pointers.